Here's okay. So what I'm noticing is there's an 8 and there's a 12 and there's a 6. It appears to be like a right angle triangle prism. So I'll show you what I'm looking at here. Why don't I do something like, I can't draw it the other way. Nope, doesn't let me draw it the other way. That's brilliant. All right, have to do it this way. So I think we're looking at something like this. So if I clone this now, so just clone this and draw it properly. Control group, clone. Okay, and what we're going to get here is, there's your triangle prism. Everybody cool with that? Yeah. So that's what we're looking at here. Now I'm going to allocate sizes for it as well. So I'm going to make the 12. The 12, I think, is the length, isn't it? Everybody agree 12 being the length? Or is it? Yeah. The distance between these 2 points here, see the black points? The distance between them is 12. Would you agree with that? So that's me drawing them like this here. Then what we have is, this is going to be the top part, isn't it? The slanted edge. So that's going to be, does it give us the length of it? Is it 8? It has to be the same size as the other one probably. Or does it? Doesn't have to be the same size as the other one. That's 6. Now which one's guaranteed to be 8? Oh, the slant edge is 8. So you're right. What's the only one this is 8 as well. That's 8. That means that can't be 8. Now here's interesting. I'm just gonna get a ruler out and measure them and see, just for my own sake, are they the same length as each other? You should just check this out yourself, just in case. So what's the length of the first one? I know it says 8, but it's roughly 4 centimeters, and the other one is bigger than 4. Oh wait, they're the same size, are they? First time in a long time I'm confusing myself. Alrighty. I know, I thought it was, but here we are. Oh, I see it now. I have it. Alright, here's what happens. Can I? Huh? Harsh. Now, this is the bottom. Would everybody be happy that this is the bottom? Actually folds around and becomes the bottom. So that's the blue section there. Okay. The next part is the red section, which I think is the diagonal section here. Does that make sense? Now, that's a right angled triangle, isn't it? So that's 8 and that's 6. So I don't believe this is 8. I believe it's going to turn out to be 10. Did anybody figure that out themselves? So call it L. L squared equals 6 squared plus 8 squared. L squared equals 100, and L will equal 10. To me, that means that's 10. Okay, so I rub out this now. So does everyone understand that this is the 2 sides here? So if I color this green, that's roughly actually this side here. If I color that side green, that's that side there. I just folded it in and turned it around. Is that okay? That's the other green side there. We know they separate by 12 because we see the 12 in between them. And then we know that the distance along the bottom is 8. And we know the height is 6. So that basically means that I have to find the hypotenuse, which is, what's the hypotenuse? 10. All right, let's see if I need that, all right? So let's go back to the question. Number of faces, what do we reckon? Well, we have it there, don't we? Just 3 rectangles, 2 triangles makes 5 faces. Is that okay? So 5 faces. How many vertices do we have? Corners. 1, 2, 3, 4, 5, and 6. 6 faces. 6 vertices. Find the surface area of the prism. All right, the surface area of the prism is quite handy. So what's 12 times 8? 12 times 8 for the first rectangle. Huh? First 12 times 8 is 96 for the first part. 10 times 12, 120. 6 times 12, 72 for that one. And a half 6 times 8. So what's a half 6 times 8? 24. And then this is also going to be 24. What happens when you add up all the individual sections together? So you add 96 with 120 plus 24 plus 72 plus 24. Anybody get an answer for me? Is that the answer in the back out of interest? So I was correct about the 10. So it was actually a tough question, believe it or not. It was quite a tough question. Okay. So 36 centimeters squared. All right. How do you do the volume? Anybody care to tell me how do you do the volume? You get the area of the face and then you multiply it by what? You get the area of the face and then you multiply it by the distance it goes backwards. Yeah? What's the area of the face? We already have the answer. What's the area of the yellow triangle? 24, isn't it? And how deep do you go? So 24 multiplied by 12, 288. All right, a rectangular sheet of metal is 2 meters by 1.5 meters. Now, we all know fractions are the devil, so we're going to change that to 150 centimeters by 200. Not dealing with meters, so we don't have to. Is that all right? So that's 200, and that is 150. Now, what we're looking at next is what does it lose? So see this corner here? See the blue corner? That's that one there, actually. The red corner would be this one here. And then I think you get the gist now, these. All right, probably do. Now, okay, you lose part of the length. It's not 150 anymore. Why is it not 150? You cut it twice, didn't you? How many 30s did you lose? You lost 2 30s, didn't you? So what does that mean? It's now 100 and? No. It's now 90 because it's 150 take away the 2 30s you lost. So it's 90 in this direction here. What is it from blue to pink? 200 take away 60, which would be 140. And the actual height is how much you folded it up by, which will be? Anybody? 30. Okay, does it want the volume or the surface area? Oh, surface area, so annoying. And volume is the second question, is it? All right, we should be all right then. All right, we can do this using the box. We can do this using the net. It's a bit easier, all right? So that's 140. What's 140 by 30? 140 multiplied by 30? 4,200. Okay, that means this one is also 4,200. All right, 30 by 90. What's 30 multiplied by 90? 2,000. There's your 2,700s sorted. Finally, 140 by 90 max. 140 by 90. There you go. Now, add them all together. Is it an open box or a closed box? It's an open box, isn't it? What happens when you add them all together? Come on, guys. Somebody add all of them together for me. Huh? 26,400. But it froze. So we're good. I think it'd be close to that. 12,600 plus 4,200 plus 4,200 plus 2,700, 2,700. What'd you get? Never doubt the froze. Now, all right, we good? All right. The really difficult part in this question is part 2, when you have to convert it back when you have to go from centimeters cubed to meters cubed to liters. That's the most difficult question you generally ask people at this level, because the conversions are tough, okay? So first of all, the volume is easy. What's the volume? 90 by 140 by 30, and what you get? 378,000. Okay, now this is easy. When you order a litre of anything at the shops, a litre is 1,000 centimeters cubed. So simply divide by 1,000 and you can turn it straight into litres, no bother. So how many litres do we get? 378 litres. So you've done part A and you've done part C. The difficulty comes in is with part B. Part B is the difficult part. Divided by 1,000. One litre is 1,000 centimeters cubed. So you divide by 1,000 to turn it into litres. I'm going to do that now. All right, lads, here's the trick. Is centimeters cubed 3D, 2D, or 1D? If it has a cubed, it's 3D. Do you get what I'm saying? So get this. 1 meter equals 100 centimeters. Everybody cool with that? What's 1 meter squared then? 100 multiplied by 100, which is 10,000. 1 meter cubed is 10,000 centimeters squared. Oh, sorry, 1 meter squared is 10,000 centimeters squared. Now, with 1 meter cubed, how many hundreds do we need this time? 3 of them. And what's 100 times 10,000? I think it's a mil. All right. All right, guys. Shh. Now, a meter cubed is 1,000,000 centimeters cubed. You got that? So how'd you convert centimeters cubed into meters cubed? Centimeters cubed is generally 1,000,000 times bigger. The number is 1,000,000 times bigger. All right. See the number 1? You are comparing that to 1,000,000. So what you have to do with any number you get? Divide by 1,000,000 or multiply by 1,000,000? You divide by 1,000,000. Okay? Because it has to be close to 1, doesn't it? Is 378,000 bigger or smaller than 1,000,000? So therefore your answer has to be smaller than 1 meter cubed. So divide by 1,000,000 and what you get? 0.378 meters cubed. Is that right? All right. Now, way to get me fired. Now, what's the first shape? Cube. Next one? Cuboid. What's this one? A square. What? Square-based pyramid. Now, square-based pyramid because it has the square base. And the last one? Triangular prism. No, there's one that has a triangular base. I'll probably show you that later on, all right? Number of faces, guys, on each one. 6 for these guys. What about the square base pyramid? Triangular prism? 5 as well. Number of vertices on this guy. Is it 8? And the box will be the same, won't it? So 8, 8. Now what about this one? 5, yeah. And the next one? Okay, grand. Number of edges. The number of lines you see making it. So, yeah, I think Sam's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 for the cube, 12 for the cuboid. Let's try this one then. 4 on the bottom, would you agree with that? And then, yeah, I think it's 5, 6, 7, 8. 8 there. And then the last one. Last one, 9. Oh, you guys are so fast. To the following trees, these solids can be made from the following nets. Now, do you see the way this one's see the way this is a triangular base? Yes. So it's going to be a triangular base, and then you're going to have so something like this. All right, and then you're going to have I think I really ruined the shape of this one. I totally botched it. Let's try this again. I think it has to be, I think it actually has to, know what the problem is? It has to be a equilateral triangle, I believe. Ooh. All right, try this again. I'm still gonna muck it up, I think. Yeah, I'm not even gonna try and draw it. All right, basically what it does is it folds to a triangular base with three other triangles on it. Okay, so this is a triangular pyramid. You get what I'm saying? Not a square base pyramid, but triangular pyramid. This one's just a cuboid, and this one is a cylinder. Okay, grand. All right, you do part 2 then.